Okay, so question 73, indicate whether each of the following is R2-chlorobutane or S2-chlorobutane. So these are actually pretty easy. They're just cookie cutter. Once you know how to assign priority, it's pretty simple from there. So let's just do sub-question A. So what we have is a hydrogen, which we've already said multiple times is always going to be your lowest priority atom, so this is 4. We have a chlorine, which is extremely high priority when compared to this methyl group right here and this ethyl group right here, because again, what we're doing is carbon to chlorine, so this is going to be group number 1. And between this carbon here and this carbon here, this carbon has another carbon attached, which is making it the ethyl. So this is going to be priority 2, and then finally priority 3. So you might fall prey to the mistake of saying that since these are 1, 2, 3, it's looking like it's going counterclockwise, so S. You would be correct in the analysis that it's going counterclockwise, but you would be incorrect in that you would have forgotten that the way that we categorize RNS is that we always have to have the lowest priority group facing away from you. So in this case, the lowest priority group is actually facing towards you. So what you have to do is, you can either do your single swap rule, or you can imagine yourself kind of in the background, your eye in the background, kind of looking towards that hydrogen, so where it would be behind you. And in that case, it would be very easy to see that this is going to be in an R configuration, 1, 2, 3. So if you're good enough to imagine yourself behind this carbon atom, you would see that this is going in a clockwise fashion. But if you're not, it's okay. It takes a while to get used to that. You can always do the single swap rule and figure it out very, very easily. So let's go ahead and do the single swap rule. So we'll have the same kind of orientation as we did before. And all we're going to do is change 2 positions. So the easiest position to change is always going to be this hydrogen because, again, the issue is that it's not facing away from us. So we need to face it away from us, which means that we have to switch it out with the methyl. So methyl's right here. And again, 1, 2, 3. So this looks as if it's S, like that. And that's correct. But then we have to remember always, 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 to once we find the configuration of the single swap, you have to invert it. Okay? So you always have to remember to invert. Okay? So invert, and that means that this molecule on the left is not S, but R. So this is going to be our R configuration, and that's that for the first one. Okay, so sub-question C is slightly tricky because you have to remember what's not shown here. What's not shown is the hydrogen. You don't necessarily have to show that particular hydrogen bond. So you have to figure out whether or not it's facing towards you or facing away from you. So you have to work with the information that you've been given. So what you've been given is that you have an ethyl and a chlorine that's in the plane of the board, and you have a methyl group facing towards the other room. So the only thing that is missing is the hydrogen that's implicit in the molecule, and since you already have 2 groups facing in the plane, and you have 1 group facing away from you, working from the knowledge that you know that this carbon is going to be a tetrahedral geometry, you have to think about the fact that this hydrogen is now facing towards you. Okay, so again, what we can do is you can recognize right away that you're going to have an issue with determining RNS simply because your lowest priority in this case is, again, going to be your hydrogen. So this is going to be priority 4. So you can go ahead and just, again, do the single swap if you'd like, which is probably the easiest way if you don't like trying to think in 3 dimensions, and that's totally fine. So it's just a little bit more complicated or convoluted, I guess. It takes a little bit more time. So you can draw out this molecule again, 1, 2, 3, chlorine here, and we're going to still have the group that's facing in the other room on the left, and the group that's facing towards you on the right. And in this case, all we're doing is switching this methyl right here with this hydrogen. So hydrogen is now facing away from you, methyl's facing towards you. And again, this is going to be the first priority, second priority because it's ethyl, and then third priority because this is methyl. Fourth priority is facing away from us, so that's fantastic. So now it looks like this molecule is going in counterclockwise fashion, and that's going to be S. Okay, but again, you have to remember that whenever you do the single swap rule, the configuration that you find is not the actual configuration, because what you're doing is you're can imagine this hypothetical situation where you are physically ripping off this methyl group and ripping off this hydrogen group and replacing them in two different positions, which is impossible for what we're doing to just determine configuration. Okay, so remember that once you do the single swap, this is not your actual answer. You have to go back to your actual molecule. Okay, because right now what you have is the enantiomer of the original molecule. Okay, so as long as you do that, you're okay. So going back to this original molecule on the left, since this enantiomer is S, this guy over here must again be R. Okay, so it looks like what we've really done is we've drawn the same molecule as an A, we've just drawn it in a different way. Okay, because again, all we have is a methyl ethyl chlorine hydrogen, methyl ethyl chlorine hydrogen. So you can take that to mean that there are multiple ways to draw the exact same molecule. Okay, but again, the other take-home message here is if you are a fan of the single swap rule method, you always have to remember to do that inversion. It's much harder to get used to thinking of this in 3 dimensions, but if you do, you never have to worry about inverting. Okay. All right, so what we have for our third question is this Newman projection. So you have to remember how many carbons are associated with the Newman projection. We have 1 carbon up here in the front, and then there's 1 carbon directly behind that. Okay, so we have 1, 2, 3 carbons, and then a 4th carbon. And it looks like these 2 carbons are anti to each other. So this carbon right here and this carbon right here are anti. So let's go ahead and redraw this, and let's redraw it in an easier to interpret form, I guess. So let's have this methyl group just kind of facing down in the plane of the board, and we'll have the other methyl group facing up in the plane of the board. Okay, so those are the 2 methyl groups. So maybe make it a little bit easier by saying that this one is yellow right here, and so we'll make this one our yellow methyl group right there. Okay, so yellow on the right, blue on the left, and what we'll do is we'll just fill in the blanks. So what we have will be, let's see if we can add a dash and a wedge, okay, and we'll add another dash and wedge, dash and wedge. Okay, so thinking about what's attached to this methyl group, for the methyl group right here, if you look to the right, we're going to have a hydrogen. If you look to the left, we're going to have another hydrogen. So this is actually pretty simple. We'll just add in our 2 hydrogens, no big deal. Hydrogen, hydrogen, no big deal. Okay, so we can immediately really discount this group right here because it's not a chiral center. We don't have to worry too terribly much about it. Okay, we may have some trouble with this guy over here. Okay, so now let's think about what we have attached to the other blue carbon. So what's attached right here? We've already added our blue methyl. So here's our blue methyl right here. Okay, so this guy right here is this guy right here. And attached to the carbon, we have to add a chlorine and a hydrogen. Okay, so thinking about this, our orientation, if we think about having our eye pointing in this direction and the methyl group's pointing down, you can tilt your head slightly to the left. If you're looking at the screen right now, just tilt your head by about 45 degrees and you'll see how this methyl group right here is facing down. And if this methyl group is facing down, as long as you continue to have your head tilted 45 degrees to the left, it looks like this hydrogen's on the left and this chlorine's on the right. Okay, so according to our perspective, this hydrogen's on the left, chlorine's on the right, and if we turn back to vertical, so the hydrogen's going to be on the left, chlorine's on the right. Okay, so let's go ahead and fill this in. Hydrogen on the left, chlorine on the right. Okay, so now it does look like we have to worry about stereochemistry on this particular carbon, so let's go ahead and assign priority. So always, 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 hydrogen is going to be the lowest, and then we have our highest priority halogen right there. And again, it looks like, yet again, we have an ethyl group, so this is going to be the 2nd priority, 3rd priority. Okay, 1, 2, 3, and then 4. And since we already have our hydrogen facing away from us, we don't have to do any more work. This is fantastic. It looks like this particular variety is going clockwise, so this is an R configuration. So That's the end of that. So the Newman projections are a little bit more in depth, but not too terribly hard if you can keep your perspectives right. Okay. All right, well, good luck with the rest of the problem.